Hey, good morning, Lorenzo. How are y'all today? Everybody feeling better? Yeah. Lucero, was it you that was out on Wednesday?
Yes,
You feeling better?
yes.
Good. All right. So, first announcements. Um, I've decided to go ahead and change the dates for exam three. I'm just going to push it to Wednesday and Friday of next week. Um, Now, what that's going to mean is that on Monday, um, um, yes, we will address any lingering questions over material from exam three, uh, and I'll take time to address any questions over that. So please look over that material. And if I don't feel like we're getting any questions addressed, I'm going to go straight into looking at assignment 22, um, systems 2x2 and 3x3 systems. So, along with reviewing, be also thinking about, especially in preparation for the following week, that you be looking at systems of equations. That's assignment 22. All right, so enough talking. Um, oh, I hope y'all saw my announcement about Quiz 10. Um, I had a couple of typos um, on the initial quiz, things that I didn't like, things that needed to be adjusted. And I didn't catch those typos until after y'all had already submitted. So all I did was I can't remember the exact problems, but I made note of that in the announcement. But there's basically 4 points, um, two problems that equated to a total of 4 points. So I just removed those 4 points from total number of points. So instead of being graded out of 35 points, it was graded out of 31 points, which was a benefit to everybody. All right, so that was my quick announcement about Quiz 10. In terms of reviewing for the exam 3, you have your review, you have all the previous quizzes that would lead up to this section, and you have uh, the homework. So, let's talk about questions. What questions do we have, either over assignment um, 21 or any previous assignments?
Number 7,
What assignment?
21.
Number 7 from assignment 21. Problem number 7, we have the log base 6 of x plus 3 plus the log base 6 of an x plus 4 equals 1. Alright, what I would do here um, is, well, I guess before I get started, I want to say that the general theme of this assignment is to convert these logarithmic equations into exponential equations. Um, but to get started, we don't like to have multiple logarithms, so I would think about condensing these two logarithms, and since there's a plus sign, I would use the product rule. Alright, so we would have the log base 6 of x plus 3 times an x plus 4 equals 1. And then at this point, I mean, you could either FOIL this right now or you could FOIL it in the next step. What I'm going to do is I'm going to rewrite as an exponential equation. So 6 is my base, so this becomes 6. 1 is my exponent, so 6 to the 1 is equal to what we're taking the logarithm of. So this becomes 6 is equal to, let's FOIL everything out, x squared. You're going to get a 4x and a 3x, that makes a 7x plus 12. And then we need to set equal to 0. So we'll subtract 6 on both sides and we get x squared plus a 7x. 6 minus 12 is going to be plus 6 is equal to 0. Okay? With me so far? So what we have here is we have a quadratic equation. And how do we solve quadratic equations? Well, if it's set equal to 0, we could use the quadratic formula. Or we might think about factoring. And I think factoring would be a good approach here. So x times x is x squared. What are the factors of 6 that add up to 7? How about a positive 1 and a positive 6? And then we would set each factor equal to 0. And that would give us x is equal to negative 1 and x is equal to negative 6. Now the temptation here is to box these answers in and move on our merry way to go to the next problem, but you have to make sure and check. Because just note that the domain of any logarithm of the log base b of x, the domain of log base b of x is anything from 0 to infinity. Basically, this means that we can only plug in positive values. Now, you look at the negative 1 and negative 6 and say, oh, well, those are both negative, so they can't work. Well, that's not true, because it's the log base b of x that must be positive. So what I need to do is I need to come back up here, and I just need to do a quick check. And I ask myself, can I plug in negative 1 and can I plug in negative 6? Well, negative 1 plus 3 is a positive 2. So I can take the log base 6 of a positive 2. And negative 1 plus 4 is a positive 3. I can take the log base 6 of a positive 3. So 1 would work, or excuse me, negative 1 would work. If I plug in negative 6, though, negative 6 plus 3 is a negative 3. I can't take the log base 6 of a negative 3, so already I could just throw out negative 6. So that means that my only answer is x is equal to negative 1. The reason you can't plug in negative 6 is because if you plug in a negative 6, either for this logarithm or in this logarithm, you get a negative value, and you cannot take the logarithm of a negative value. So, if you had gotten through this, I imagine your question is, why can't x be negative 6? Well, there's your reason why x cannot be negative 6. Because if you plug in negative 6, you get undefined values for your logarithm. Does that make sense? Great. Alright, what else can we look at?
You said we can ask about previous assignments too?
Sure.
Can we go over 15 on assignment 20?
15 on assignment 20. Okay. 15. We have 5 raised to the 2x plus 3 is equal to 3 raised to the x minus 1. All right. Now, because the 5 and the 3 are not the same base, if this was 5 raised to 2x plus 3 is equal to 5 raised to x plus 1, I could just set my exponents equal to each other. But they're not the same base. So what we want to do is we want to get these variables out of the exponential position. And the only way to do that is to take the natural log on both sides, and then apply your power rule for logarithms. Now, it's important to realize that when you do this, especially when you have this polynomial expression, you have basically a variable term and a constant, variable term and a constant, that the entire exponential expression gets multiplied by the natural log of 5. The entire exponential expression gets multiplied by the natural log of 3. Alright, so now we've gotten our x's, our variables, out of the exponential position. Now it's a matter of getting x by itself. This is one of those problems where I don't like those parentheses, so I'm going to distribute. So we have 2x times the natural log of 5 plus 3 times the natural log of 5 is equal to the natural log of x minus the natural log of 3. Okay, remember what our goal is. Our goal is to get x by itself. And I want to also remember that, natural log of 5, natural log of 3, oops, I misread that, didn't I? Sorry, that's going to be x natural log of 3 minus the natural log of 3. Sorry. Natural log of 5, natural log of 3, they're just numbers. That's all they are. But we don't want to express them out as numbers because that would be just way too many decimal values. What I want to do is I want to get my x's on one side and my variable terms on the other side. So I want to get this whole entire x natural log of 3 on the other side of my equation. So that becomes 2x natural log of 5 minus x natural log of 3. And just like I wanted to get my variable term on the left, I want to get my constant term. Now this is a constant term because it has no variable. I want to get this on the right hand side. So this becomes minus natural log of 3 minus 3 natural log of 5. Good so far? Now the trick here, it's not really a trick, but it's just a thing that once we experience this enough, we know what to do. What we want to do here is we want to factor out the x from these two terms. Okay? Then, remember, this is just a constant. Now, I can't make this any simpler, but this is just a constant. This is just like saying x times some constant equals something else. How do you get rid of that constant that's multiplying x? You divide both sides by the constant. So you get x is equal to, we have minus natural log of 3 minus 3 natural log of 5 over 2 natural log of 5 minus the natural log of 3. Now, if you look at the answer key, that's not exactly how the answer is expressed in the answer key. But this is a form of the correct answer. In fact, if you were to evaluate this expression, you would get the same approximation that I did in the answer key of a negative 2.7954. So how do you get this to look like the answer that's in the answer key? So the first thing I would do is I would factor out the negative in my numerator. And so if you're looking at the answer key, you might be saying, oh, that's how we got the natural log of 3 plus the 3 natural log of 5. And at the same time, this is going to be look a little bit quirky. I'm going to factor out a negative in my denominator. So this becomes minus 2 natural log of 5 plus natural log of 3. Okay, well, what do two negatives make? A negative over a negative becomes positive. Negative divided by negative is positive. So I don't have any negatives in front of my parentheses anymore. And just to make things look like the answer key, since these two are both positive, it doesn't matter. I mean, basically we're just adding terms right here. It doesn't matter what order I add the terms, so I can rewrite this as 3 natural log of 5 plus the natural log of 3. And again, since I'm just adding terms down here, I can just rewrite this as the natural log of 3 minus 2 natural log of 5. And that's how we get it to look like the answer key. So I want to make a couple of quick statements. At this level, I'm going to be okay with that answer right there. I'm going to be okay with that answer. We just can take some extra steps to get to this point right here. So, two questions. Does it make sense how we got to this answer? And does it also make sense how we get from this answer, doing a little bit of manipulation to get to the answer as it is expressed in the answer key? Make sense? Okay, good. What else can we look at? Any other questions?
Can we go to assignment 19?
Yeah, what about assignment 19?
Can you do 1L?
1L. Okay, so as far as properties go, I'm sure there's a property out there that says e to the natural log of x is going to be equal to x. But why? I mean, why is that true? So what I would do is I would set that equal to y, and I would go and I would work to rewrite in the logarithmic form. Rewrite it as a logarithm. So as a logarithm, this is my base. So we have the log base e. This is what I'm going to take the log of. Log base e of y is equal to, and this is what the logarithm equals. Equals the natural log of 31. Okay, so one thing I got to remember is that the log base e is the same thing as the natural log, so this becomes the natural log of y is equal to the natural log of 31, which just means that y is equal to 31. So that means that our initial problem, natural log e raised to the natural log of 31 is equal to 31. Does that make sense, Alex? Okay. What else can we look at? You know, something that I'm always thinking about whenever I'm dealing with exponents and logs, I'm always thinking about that relationship. If y is equal to the log base b of x, that the equivalent exponential form is b to the y is equal to x. I'm always thinking about keeping that relationship on the tip of my mind. In fact, I would advise that anytime that you encounter a quiz or a test, you just jot that down. Have that in your back pocket. That way you don't have to think about it so much. You just jot it down and you know where it is, and you can be thinking about that as you go through a quiz or exam or your homework. All right, any other things that we can look at? So, are we ready to take the quiz? All right, let's go ahead and take the quiz. Alex, you good? He's good. All right. So, I'll go ahead and ask the facilitator to distribute the quiz. The link and Gradescope for week 11 quiz is available. So, we'll spend the rest of our time answering the questions for doing the quiz. Remember, on Monday we will review for exam 3. So please take the opportunity to look over that review, look over previous problems, so that our time on Monday can be well spent answering any lingering questions. All right. I'll just be quiet now while y'all get some work done.
Your conference is scheduled to end in 2 minutes.
Okay, as y'all are wrapping up the quiz, I'm just gonna give some closing remarks. I'll see y'all on Monday. We review on Monday for exam 3. So, make sure that you spend some time this weekend, developing questions that you wanna have addressed, on Monday. So other than that, I'll see y'all later. And hopefully we don't have any issues with the submission this week. We'll see. Take care. Bye.
Your conference is now over. Goodbye.